Alright, hello, this is Chris Evans, and this is the reassessment for the Kinematics assessment that we did in class. And the problems are already in the email and stuff. And I know there's a whole bunch of numbers listed here, but like you said, apparently you don't care about numbers, they bore you. So I'll just, like I said, the problem's already in there about the car that passes up into a slower car. But so basically, but we have the initial velocity, the final velocity, and the time it took to and the total time. But we need the distance and the acceleration, so we just use the regular kinematics equations, like final velocity in the horizontal direction equals initial velocity plus acceleration times the change in time. And in order to do that, we can I'll put the numbers in here, which you just rearrange that. You would do you would subtract the horizontal. Sorry, the video quality is pretty bad. The horizontal. The horizontal final velocity minus the initial velocity over the change in time, which would equal the acceleration total. And I know that was the second part, but I used that acceleration to plug into the formula of to find the distance, which the original formula is final velocity squared equals initial velocity squared plus 2 times acceleration times the distance. And so I just rearranged and got velocity, the final velocity squared minus the initial velocity squared over 2 times the acceleration, which was found in the original and in the first equation, one that I did. So and that's how you do that first problem. It's just rearranging basic algebra, rearranging formulas. But I know, of course, that you have to find each part first. Like you have to, so we know the initial velocity, we know the final velocity, we know the time, and so you have to know what we have. You have to know what you have in order to solve for it. So. Okay, and for the second part, again, the problem is in the email, and and I won't bore you with numbers, but we are dealing with the vertical plane, up and down, because of the ball being dropped or being thrown up, whatever. So so basically, we know the initial distance is 1.0 meters. Well, it's the distance that the horizontal plane is above the ground, from which the ball is shot off or thrown, and then we're looking for the final distance. And so I started off. I multiplied the velocity times the horizontal direction, or velocity. So I got to put, and basically sine is opposite over hypotenuse, so the sine of 30 times 19.6 meters per second, and I got 9.8. And then you use that 9.8 to plug into the formula, and end up with the same formula that we used. One of the kinematic equations, is the final velocity equals the final velocity squared equals initial velocity squared plus 2 times acceleration times the distance, and basically just rearrange for that. And the final velocity, of course, is 0, because at the top of the point it's going to be 0. And but the initial velocity, it's negative at first, but of course when we plug in 19.6, it's squared, and then divided by 2 times the acceleration, which the acceleration is negative 9.8 since it's in the vertical plane. And then once we have that value, then we add 1.0. We add the 1 meter, because that's how much it is above the ground, and that gives you the maximum height of the equation. And that is that of the kinematics reassessment. I hope you enjoyed it. Goodbye.